It will continue to lose material and in 1 to 3 million years go supernova, blasting everything but its core into space. In the year 1841, Eta Carinae, a star just 8,000 light-years from Earth, did explode. Though it released as much light as a supernova, it survived, expelling gas and dust in the form of 2 polar lobes and a large equatorial disk. This cloud of matter is about 10 billion miles across and is still expanding at about 1.5 million miles per hour. Compared to the Sun, Eta Carinae is estimated to have about 100 times more mass and to radiate nearly 5 million times more power. Another dying star is the aging Wolf-Rayet WR136. It created this web of luminous material by expelling mass some 250,000 years ago. Around the star, the expelled material formed a shell which we call the Crescent Nebula. Typical of most Wolf-Rayet stars, a fierce stellar wind of charged particles is blowing from the surface of 136. When it collides with the shell of gas, the wind breaks the shell into bright clumps and strips material from its outer edge. The space between stars is not empty. Space is filled with various kinds of immense clouds of elemental gas and dust called nebulae. In fact, nebulae are the very material from which stars, planets, and other cosmic bodies are formed, and to which they return when they die. Some of the larger ones, the giant molecular clouds, for example, are 1 million times more massive than the Sun. Reflection nebulae are those that are visible because they reflect starlight. Within these strikingly beautiful bodies, it is common to find clusters of stars in the process of being born. Barnard's Merope is a reflection nebula about 380 light-years from Earth. It looks like an array of wispy tendrils, but it's actually a dark cloud illuminated by the star Merope in the Pleiades star cluster. Ironically, the same radiant energy that makes the nebula visible is also destroying it. About 1,500 light-years from Earth, near Orion, reflection nebula NGC 1999 glows with the light of the star it surrounds. This bright new star, V380 Orionis, is white because of its high surface temperature. At about 10,000 degrees Celsius, it is nearly twice that of the Sun. The nebula is material left over from the star's birth. The black cloud at the center is called a Bok globule, a dense, cold cloud of gas that blocks all light. The Carina Nebula, over 200 light-years in diameter, contains a large dark loop which is actually part of the Keyhole Nebula. About 8,000 light-years from Earth, Carina lies near Eta Carinae and several other hot massive stars. The hot fluorescent gas filaments and dark clouds of cold dust seen here are in rapid chaotic motion. The pillars and knobs at the upper left point toward the star that is illuminating and sculpting the clouds with its radiation and stellar wind. The Horsehead Nebula, Barnard 33, is classified as a dark nebula because it blocks the light from the bright object beyond it. Dark nebulae are physically similar to reflection nebulae. About 1,600 light-years from Earth, just south of Orion's belt, the Horsehead is silhouetted against the bright nebula IC434. The clouds above the Horsehead are being illuminated by a young star born in the nebula. It is emitting radiation that will gradually burn the nebula away in a process called photoevaporation. Emission nebulae are hot gas clouds whose atoms have absorbed energy from ultraviolet starlight. When they release this energy, these atoms glow, often with red light from the hydrogen they contain. The vast amounts of gas in emission nebulae often condense to become new stars. Nebula 3603 is an emission nebula in the Carina arm of the Milky Way, about 20,000 light-years from Earth. This remarkable image includes examples of nearly every stage of stellar evolution. A compact cluster of young hot blue stars lies near the blue supergiant Schur 25, surrounded by the ring of gas the star ejected about 7,000 years ago. Blobs of gas ejected by nuclear explosions on Schur 25 float perpendicular to the ring. Small dark Bok globules and the huge pillars of gas and dust among which they're scattered hold millions of new and still-forming stars. The gas of the Lagoon Nebula, 5,000 light-years away towards Sagittarius, has been twisted into a pair of half-light-year-long ropey funnels. Scientists speculate that they may come from a horizontal shear produced by the great temperature difference between the hot surface and cold interior of the clouds, plus the pressure of starlight. The stars are also photoevaporating the clouds and tearing them apart with violent stellar winds. The beautiful Rosette Nebula, 5,500 light-years from Earth, is an emission nebula created by an open cluster of stars at its center. Open or galactic clusters are loose groups of a few hundred young stars that eventually disperse. This cluster is expelling immense clouds of hot gas and energizing the atoms of the clouds with ultraviolet light. The atoms emit the radiation in the form of red light, the signature color of the hydrogen that is so abundant in the cloud. The beautiful dramatic Eagle Nebula M16 is a star-forming region 7,000 light-years from Earth in Serpens. The nebula contains dense pockets of interstellar gas called evaporating gaseous globules, or eggs. The eggs are inside the tips of light-years-long columns rising from monstrous pillars of cold molecular hydrogen gas and dust. Inside the columns, the gas is so dense it collapses under its own weight and eventually grows into stars. A torrent of ultraviolet starlight has heated the top surface of the pillars, photoevaporating the gas into space as ghostly streamers rising from the cloud. The eggs made of denser gas are left behind, and ultraviolet light uncovers the new stars forming in them. The Orion Nebula is found 1,500 light-years from Earth in the sword of the constellation Orion. It is a well-known site of star formation, but deep in the nebula's center in the Trapezium star cluster, Hubble's near-infrared camera saw the exception to this. Around the massive bright stars here is a swarm of about 50 newborn brown dwarfs. These glowing star-like objects have such little mass that their cores never get hot enough to fuse hydrogen. They never become stars that shine steadily, but soon fade and cool. This 1994 image of Orion not only reveals some of the stars that did form there, but shows enormous disks of dust circling around at least half of them. These disks, or proplyds, have the potential to snowball, then pull together under gravity and grow into actual planets, just as Earth did 4.5 billion years ago. Scientists hoped this meant planet formation is common across the galaxy. They also inferred from this image that while stars no bigger than our Sun probably have proplyds, hotter stars may destroy their potential planets before they actually form. Taken in 1995, this image of Orion clearly shows the nebula's thousands of new, rapidly forming stars. It also reveals proplyds encircling the young stars, further encouraging scientists' hope for discovering planets. These newer pictures show some of the hazards of planetary formation. They are the first images of proplyds beginning to form, when dust grains are just starting to agglomerate into disks. But the new proplyds here are being photoevaporated by radiation from a neighboring star, leaving tails of gas boiling away from their disks. This suggests that planets must form quickly to avoid being destroyed by stellar radiation. If they cannot, there may be fewer planets in the Milky Way than we first hoped. Another emission nebula, the Trifid, lies about 9,000 light-years from Earth in Sagittarius. At the upper left of the towering garden of stars, a wispy trail of gas is ejected from a star forming within the cloud. 3/4 of a light-year long, the stream of gas is glowing in the radiation of the nebula's massive central star. The stalk to the right enshrouds an evaporating gaseous globule, which could form into a star. A different kind of nebula is not the fuel for a star's birth, but a sign of its death. When an especially massive star dies, it creates an amazing blaze of glory called a supernova. Though they endure just for a few days, supernovae emit as much energy as an entire galaxy. Afterwards, much of the star is blown into space to become a supernova remnant. In the year 1054 AD, astronomers in China saw what they thought was a new star, for weeks so bright it was visible in daylight.